let us now talk about how to find the domain of a radical function and rational function. So we'll begin our discussion with the radical function. Any function that is in a square root, we call it a radical function. So now, how do we find the domain of a radical function? Let us try to understand something. Anything that is in the square root, we know that in the square root, if we have negative number, that is undefined. Definitely we know that if we have with f of x is equal to negative any number, that is undefined. We are trying to make the function to be defined, therefore the only thing that we can have in the square root, it is starting from 0 going to positive infinity. Therefore anything that is in the square root, just get the way it is. How do we find the domain? So you say domain, you underline, get what is in the square root only, x squared minus 4 greater than or equal to 0. So for x squared greater than or equal to 4. Initially let me just make things clear here. When I get the square root here, it's going to be x is greater than or equal to, I'm getting the square root this side and this side, then here to plus or minus, so it's plus or minus 4, plus or minus 2, sorry. Now one thing I want you to understand is that another person can come and say x squared minus 4 is the same as the difference of two squares, where you say this, because that is going to be the same as that. It's the same, greater than or equal to 0. It's probably the same. I shift this to the other side, x will be greater than or equal to 2, another one will be x greater than or equal to negative 2, which is the same with what I have here. So you choose what to do. Now what I'm going to do here is after finding these values, whenever we're talking about how to find the domain, when we're talking about the radical function, the square root, this square root, one thing you have to understand is that if you have got more than two values, it will always go back to inequality. So these are the critical values that I've found. So my critical values are x is equal to negative 2 and x is equal to 2. Then I have to come up with a table. Okay, I have to come up with a table. So this table, I'm going to have negative 2 here and 2. I believe, guys, you know about inequalities. So I'm going to put the number that is greater than 2, that is going to be 3. The number that is in between negative 2 and 2, I can choose any, but 0, negative 3. So what I'm going to do now is, if I shift this to the other side, it's going to be x plus 2. If I shift this to the other side, it's going to be x minus 2. Then the last column, you put in these two, like that. The next thing that you do, is now you start plugging in the values. So when you plug in negative 3 where there is x, it's going to be negative 3 plus 2, it is negative 1. So I'll just put negative. If I put negative here, it is going to be negative 3 minus 2, it is still negative. So negative times negative, it is positive. I circle it like that. If I put 0 here, it's going to give me what? If I put 0 there, it's going to give me positive 2. Again, if I put 0 here, it's going to be 0 minus 2, negative. So the overall is negative. Okay, now let us look at 3. If I put 3 there, 3 plus 2, it is plus. 3 minus 2, it is 1, which is plus, again plus. The most important thing that I want you to understand is that the sign that we are dealing with, it is greater than. So if it is greater than, you get the part giving you positive. So this part and this part, and not this part. What does it mean? Any number from negative 2 included all the way to negative infinity, and any number from 2 all the way to positive infinity, but not numbers in between negative 2 and 2. So then the range, the domain in this case is going to be from negative infinity all the way to negative 2 union. Then I'll jump now. Okay, I'll jump there. I'll say, so negative 2 is included because we're dealing with greater than or equal to. So if we're dealing with greater than or equal to, that is included. So we'll say it is included union, again 2 all the way to positive infinity. That is my domain. Based on this, I believe you can manage to solve part 2, which is B. Okay, it will be the same as long as you've got more than one solution. It's an inequality. Put it on the table, find the solution that is going to satisfy the what, the function. So let's now do this one. So the domain is x squared plus 9 greater than or equal to 0. Let us look at that one now. So looking at how that question is, we can clearly see that if I shift that other one going to the other side, what's going to happen? What is going to happen here is that the way this question is, if I shift this, is going to be greater than or equal to negative 9. You can't square a number and get a negative. There is a deal here. Let me show you something. You can't square a number and getting a negative, so this can't work. So I can't use this method. Once you notice that it is a radical function and it is failing to give you the x values, the only thing that has to come in your mind is that the domain is that any number that I'm going to put here from negative infinity all the way to positive infinity, that's the domain. I can put any number here, negative, positive, still is going to come out as positive in the square root, because if I square the negative, it will give me the positive. It's different from the first one because the first one there's a negative here. If I get any number, let's say I get negative 1, negative 1 squared is 1. 1 minus 4 is negative 3, which is undefined. But in this case, because there is positive in between, then any number can fit. So the domain is from negative infinity to positive infinity. Simple. Okay. Now I'll jump and also go to part E and F before I do C and D. F and D. So just get what is in the square root. 2x squared minus 5x minus 7 greater than or equal to 0. So for x, product is negative 14, sum is negative 5. We can clearly see that the factors will be negative 7 and positive 2. Okay, so that is going to be 2x squared minus 7x, okay, then plus 2x minus 7 greater than or equal to 0. We are solving for x. I've ignored this part and replaced with the factors. Let's now factor x. X will be equal to 2x minus 7. Here factor out 1, 2x minus 7 greater than or equal to 0. Then I've got x plus 1 and 2x minus 7 greater than or equal to 0. So for x, let's get rid of this. We are solving for x. X plus 1 greater than or equal to 0 and 2x minus 7 greater than or equal to 0. So x will be greater than or equal to negative 1. Then here it will be 2x greater than or equal to negative 7 or positive 7, not negative 7, divided by 2, divided by 2. X is greater than or equal to 7 over 2. Now let us look at something here. Now we have got, like I said, we have got more than 2 solutions. So then you say critical values. So what is happening here now is we have x is equal to negative 1 and x is equal to 7 over 2. So what do we have? But remember, we still have these are the things I'm going to use when putting them on the in the table. So I'll do this. I have this. So now the number that is the least number has to be here, that is 7 over 2. No, it's supposed to be the opposite. It starts from this line, 1 negative 1, then 7 over 2. The number that is greater than 7 over 2, we know that 7 over 2 is 3 point something. Just put 4 or 5, it's fine. Then here I'm going to put the number which is between negative and positive, just put 0. Here I'll put negative 2. Then you write now these x plus 1, 2x minus 7. Then here you put these 2. Then now when you do this, now you start now plugging in the values. Negative 2 into x plus 1. So it will be negative 2 plus 1, which is negative. There is going to be negative 4, still negative. Overall positive. Negative times negative is positive. 0 there is going to be plus. 0 here is going to be negative. Overall will be negative. If I put 5 there, it will be positive. 5 here positive. Then this is going to be positive. Remember, we are dealing with positive here. We are dealing with greater than or equal to. Therefore, this is my answer and not this. So then the domain is starting from negative infinity to negative 1 union, but negative 1 is included because it is greater than or equal to, union, again starting from 7 over 2 all the way to positive infinity, like that. That's my domain. You do the same for part F. Try to do part F. Type the answer in the comment section. I'll be able to check it out and I'll tell you if at all the answer is correct that we're going to find. Okay, now let us do part C, which is the rational function. How do we find the domain of a rational function? You can never have a situation where f of x is equal to a number over 0. If that's the case, you can't have 0 over 0 at the same time. If that's the case, then we say just get the denominator, set it not equal to 0, solve for x. In a case of the first one, the domain will be get the denominator, set it not equal to 0, solve for x. What is the product? Product negative 16, sum negative 2. What are the factors? Not negative 16. Where are we getting negative 16 from? The product is negative 8. Okay, we are doing A times C. So 1 times negative 8 is negative 8. Sum is negative 2. Factors. What factors do we have? So let us see. It should be 4 and 2. So negative 4 and plus 2. Negative 4 times 2, positive 2 is the negative 8. Negative 4 plus 2, negative 2. So then we are going to have, I'll continue from here. X squared, ignore negative 2, then now focus on this. Replace it with that. Not equal to 0. Then factor out x, x minus 4. Factor out negative 2, x minus 4. Not equal to 0. So then x plus 2 and x minus 2 should not be equal to 0. Therefore x should not be equal to negative 2 and x should not be equal to 4. What does it mean? The domain is telling us the only number that we are not supposed to include is negative 2 and 4. But any number is going to fit. So the domain will be from negative infinity all the way to negative 2, not included, union, again from negative 2 all the way to 4, 4 not included, union, again from 4 not included all the way to positive infinity. That is my domain. That is something that is not complicated, but you are supposed to know it. It's something that is very simple, guys. Let us look at the last one. Let us look at the last one. So the last one is saying just get the denominator, x to the power 3 minus 16x not equal to 0. Here I can do direct thing. Factor out x. You remain with x squared minus 16 not equal to 0. What does it tells you? It tells us that x should not be equal to 0 and x squared minus 16 should not be equal to 0. Then this is a difference of two squares. Then it can be written as x minus 4 and x plus 4 should not be equal to 0. Or if you want, you can shift 16 to the other side. You're going to get the square root, so it's going to be plus or minus. So x will be not equal to 4 and x will be not equal to negative 4. Now, how do we write the domain? Now we have got a lot of values. Let's see. So the domain will start from negative infinity all the way to the negative number, which is negative 4. Cross. It is not included, that one is just open. Union. Again, it has to start from the same number all the way to the next number is 0. Cross. Again, what is the next number? The next number again from 0 itself all the way to the last number, that is 4. Again, I have to say union. I jump again from what? From 4 all the way to positive infinity not included. That is my domain. Does that make sense? Yes, it does. Yes, it does. So I had to factor out x, like we said. Yeah, so that is my domain. That is my domain. So that's how we find the domain of a rational function and the radical function. Okay. For now, let's focus on the range. If at all I have got a graph, I'll give you an example. The graph is like this. The domain in this case, we focus on the x values. These are x values and these are y values. The domain we're looking at where the graph is going in x. We can clearly see that it's just going there, it's going there. So it is from negative infinity to positive infinity using the graph. And the domain of any linear function like this one here, it is from negative infinity to positive infinity, or we say all real numbers. All the number that I can put here is going to make the function to be defined. But what of the range? The range, we're talking about the y values, okay? Now, the y values, you look at the graph. Where is this graph starting from? So let's assume that this point, it is positive 2. The graph is starting from 2, but it is going all the way to positive or to negative infinity this side. So then we start with negative infinity to 2. Is 2 included? Yes, so I will say like this. That is included because at that point the graph is passing there. Okay, now I've given you the overview on how to find the range. Let us now look at the first question. Now I want you to understand one thing. Whenever we're talking about linear function, or when you want to sketch the linear function, we look at what we call, it is in a form of f of x is equal to ax squared plus bx plus c. So mostly we look at a. If a is greater than, let me start with less than a, the graph is going to curve like that. If a is greater than 0, the graph will curve like that. Now, this is what is going to tell you how the domain is going to be. Sorry, how the range is going to be. So you focus on a. Let us look at the first one. The first one here, it is saying as x squared. That is a. Now a, it is positive. So if a is positive, the graph has to curve like that. If the graph has to curve like that, the last number here, the curve, if this is the graph here, let me first do this. If this is my graph, the number where the graph is going to be, we look at this number which doesn't have x. The number that doesn't have x in this case is 7. So 7, I will say maybe 7 is here. This graph, it has to cut somewhere like this. I use this, it will be like that. It will cut on 7. It goes like that. Okay? But forget about the graph for now. This graph, I just want to show you how it's going to look like. So it is starting from 7, positive 7, all the way going upside. So the range in this case, it is 7 is included. So 7 to positive infinity not included. That is the range. So the key part is, look at x squared. Is a positive or negative? Then get the nature of the graph. Don't sketch, but just look. Is it going to go upside down, or upside? Is it going to go up or down? Then now look at the number which doesn't have x. So for example, let us look at now the second part. This second part here, if we can clearly see here, guys, it is telling us to say we have 16 x. Now in this case, a is, this is, now a is what? Negative 1. So it is negative. What does it tell us? It tells us that if it is negative, it's going to curve like that. Now it's going to positive infinity. Now we look at the number which doesn't have x. This is the number which doesn't have x, meaning that it is actually from 16, from positive 16 to negative infinity, but we start with the negative side. So it is negative infinity all the way to 16. 16 at that point is going to be included. So it's like this. This is 16. The graph will curve like that. But we're not interested in the graph. We just want to find the range. So that's basically how we find the range of a linear function. So now I will go direct to part E before I go to part C and D. If we look at this question clearly, okay, how can I find the range? Look at it, guys. Just clear. Just look at it. Okay, so we are now solving E. Let us look at E. You look at the number. Now this one is going to be different. Okay, this one is going to be different. How is it going to be different? Let us see the difference which is going to be there, because here I've got these ones. I was considering that because I didn't have any number that has just x. Now in this case, it is 3. It is 3x squared minus 6x plus 12. So I can't say I'm going to get that number. In that case, I can't say that. Okay, so what's the best way on how we can find actually the range of what? Part E. The best thing that we can do, guys, is let us first go ahead and identify A. Okay, so A is actually greater than what? Greater than 0. What tells us? The graph is going to curve like that. After knowing that the graph is going to curve like that, then we have to find what we call the minimum value. Okay, so where is the minimum value going to be? If I find the minimum value, that minimum value, I'm going to, what I mean is the minimum value, it is the point where the graph has to turn. Okay, does that make sense? So what I'm going to do is to find the minimum value, we use this formula. We'll say x is equal to negative b divided by what? Divided by 2m. So what is b? Is negative 6. So negative will cancel, have 6, 2, then 3. That gives me what? That gives me 6 over 6. So it's going to give me 1. That it means that x is equal to 1. So now when x is equal to 1, let's find the value of y. So we're trying to find now the value of what? Of y. So we have this. What are we going to have? When x is 1, the value of y is where is it? We're finding the minimum value. That is going to be 3, 6 plus that. So that is going to be negative 3. Or we can start with this. That's 5. Okay, yeah, it's 5. 5 plus 3 is 8. So f of 1 is 8. So now this one, why am I doing this? Because I have got a number that has got just x and not x squared. These ones I was doing direct because it was just direct. Okay, so this one I have to find the minimum value. This minimum value is the one you are going to follow now. Since it is positive and the graph is going to curve like that, what comes in your mind? It is the range starts from 80, from the minimum value, all the way to positive infinity. What has helped me to find here is the minimum value, which is 8. Okay, then since it is greater, a is greater than 0, then the graph is going to curve like what? It's going to curve like that. So it's going to positive infinity. So that's why it's 8 to positive infinity. Using the same concept, let's go ahead and find for part F. So part F, first of all, let's identify a is what? Less than 0, because it is negative 2. What comes in our mind? The graph is going to curve like that. So what should come in our mind is that it will go all the way to negative infinity. But we don't know the minimum value. In that case, we call not the, if you have got a less than 0, we have got what we call the maximum value. If you have got a less than greater than 0, we have got the minimum value. That's why I was finding the minimum value. So in this case, we are going to find what we call the maximum value, but the formula is the same. So x is equal to negative b divided by 2a. So negative, it will be negative 8 to negative 2. So it will be negative 8 over positive or negative 2, 4. So the answer is what? 2. What comes in our mind? Let us see. Okay. After finding x, this is the value of x. Now I'll go ahead and plug in the values. So I'll say f of 2 is equal to negative 2, where there is x, we put now 2, this value, plus 8, then 2 minus 9. So this is going to be 4, negative 8 plus 16 minus 9. This and this is going to give me 8. 8 minus 1 is negative 1. What does it tells me? So the graph now, we already know that it is a maximum, so it is like this. It will go all the way to negative infinity. The number that is going to start with, it is the number that we have found after plugging in the value. Does that make sense? So that means that it is from negative infinity to negative 1, but negative 1 included, this not included. That is the range. If I want, I can go back. The same method I was using for finding the minimum and the maximum, even part A and part B, it can also still work. Only that this question is the same as f of x is equal to x squared plus 0x plus 7. So it will be x is equal to negative b over 2a. b is 0. Any number divided by 0 is c. So that's why we don't consider using this formula, because it will still give me 0. Okay, so that is it for linear function. Now let us focus on the rational function. This is what we call the rational function. To find the domain of a or the range of the rational function, there are two ways. I'm going to show you two ways. The first one, you can either find the inverse of the function. So let us find the inverse of the function. The inverse of the function is going to be, we replace that with y, 2, 3x minus 4. I divide there by 1. Let's make x as a subject of formula. 3xy minus 4y is equal to 2. What else? 3xy is equal to 2 plus 4. I'll divide both sides by 3x, so it's 3y. I'll divide both sides by 3y, even here, 3y, here there is y. Therefore, x is equal to 2 plus 4y divided by 3y. So you focus on the denominator. Set the denominator not equal to 0. 3y should not be equal to 0. Okay. Then make y as a subject of formula divided by 3 by 3. Y should not be equal to 0 over 3 is 0. What does it mean? It means that the range You can even put it in set bit notation. Range, you can say y is such that y is not equal to 0 and y is a member of all real numbers. Or you can say the range starting from negative infinity all the way to 0, but 0 should not be included, union from 0 to positive infinity, meaning 0 is not part of it. That's why it is not closed. Okay, that's the range. Another method that I'm going to show you is a very simple method. There's what we call, there are only two principles. If at all the function is bottom heavy, what do I mean when I say the function is bottom heavy? The denominator, or the degree of x on the denominator, is higher than the degree of x on the numerator. We can clearly see that this is 3x. On top we don't have any x. If that's the case, then y should not be equal to 0, direct. Then you say range negative infinity to 0. It's the same thing, union 0 to positive infinity. You can either use set bit notation, that's okay. Okay. Now, what if the numerator and the denominator have got the same degree of x? For example, the part D. If they have got the same degree of x, you say y is not equal to, you divide the x divided by 2x. So you divide in short we say you divide the coefficient of those things. But it's the same thing because x and x will cancel out. Therefore, y will be equal to x and x will cancel out, it will be 1 over 2. So the range is now y is such that y should not be equal to 1 over 2, comma y is a member of all real numbers. Another thing I can say, the range is from negative infinity to 1 over 2, union 1 over 2 to positive infinity. That's the range. So there are only two principles. The function is bottom heavy, the y value is not equal to 0. Another principle is that when the denominator and the numerator have got the same degree of power, like the same degrees of x powers, then we divide the coefficient. In this case, I've divided x over 2x. X and x will go, so 1 over 2. That is it for question 4, and that's how we find the range of linear function and rational function. Yeah.